So in this video, I'm going to solve some of the BARC physics problems that came in 2023. So let's see. The first question says that uh, the eigenvalue of the matrix. The matrix is given 2 minus 3 0, 2 minus 5 0, 0 0 3. So options are, so these are the options given. So how we can do this? We are just going to eliminate the options. You can see that we know that the sum of the eigenvalues is nothing but the trace of the matrix, and the determinant of the matrix means the product of the eigenvalues, right? So we can do one thing. Let's find the trace of this matrix. See, 3 plus 2 is 5 and minus 5. So the trace of the matrix is 0. So let's check the options. It's minus 1 1 0 3, so no, 0 is not coming, so A is not the correct answer. This might be correct. Minus 4 and plus 4 is 0. Yes, it has a chance. So this has a chance, and this is minus 5 plus 3. No chance. So obviously the correct answer should be between B and C. So how can we solve this? Let's find the determinant of the given matrix, which is 2 minus 5 0 0 5 plus 3, just by just finding the normal determinant of the matrix. In So it's minus 12. So what I have told, the product of the eigenvalues is the determinant. So let's check. It's, we're getting plus 12 if we multiply all the things, and we're getting minus 12 from here. So the correct answer should be C. So let's go to the next question. So this question is saying that we need to find the derivative of the given expression. So for doing this, you need to know one formula regarding the derivative. If you do the derivation of a to the power x, it's actually a to the power x logarithm with a base e uh, with a. Okay, so we'll just apply this formula and we'll be able to do the problem. So d dx of x ax. So let's make this a constant and to the derivative of x, which is 1, and e to the power x log e. E means here, fine. Yeah. So final answer is this. Let's do the next problem. So the next question says, if we heat a diamagnetic substances, what will happen to its susceptibility? So I am just writing the expression of susceptibility, which is this z square n and not square 6n. Okay, so you can see that there is no dependence on temperature, and I hope you know this graph. If you just increase the temperature, the susceptibility doesn't change. So the correct answer should be it remains same. Okay, let's move on the next question. So the fourth question says that we have 1 mole of an ideal gas which undergoes a reversible isothermal expansion. This is important at temperature T from V to 2V2. I mean, V1 is V and V2 is 2V, final volume, the change in entropy. So, for 1 mole of an ideal gas, the formula for isothermal expansion is this. So, if you apply the first law of thermodynamics, it's delta U minus delta Q minus W. And for isothermal, this one is 0. And so we can write this. We just, so Q upon T is nothing but the change in entropy, which is R, sorry, R ln 2V, which is the value of V2, and V1 is V. So the final answer should be this. Okay, let's move on the next question. We need to find the current through the load resistance RL. So for doing it, what we need to do, you should check that this diode is in on state or off state first, which you can do it. You will see that it's actually in on state. So the voltage across this resistance is 10 millivolt, sorry, 10 volt, and fine. So just apply this. Uh, yeah. So, so let's say another question. For 1D box, we have not box actually a kind of potential, that is harmonic oscillator potential is given. We just need to find the energy, expectation of energy, and it's also given the wave function. To be noted, it's actually half oscillator. We're going to write like this. So let's put the values. Mm, the formula for half oscillator is given by actually this. Let's put 0 first. So it's 3 by 2. And if we put 1, it's actually becoming 7 by 2. Fine. Yeah. So 4 by 5. And the probability is 1. Sum of the probabilities. So the final answer should be 31 upon 10. It's okay. I have another question. is saying that in 1D potential box, the number density, yes, is it proportional to E 1 upon root E or root E? E means the energy here, or 1 that is independent. So how can we do this? So density is actually proportional to this. Okay, so you just put the values. D is the dimension. Okay, and S means that dependence of E at this power. In 1D potential, we know it's P squared. So here S is 2 here. So you just put the values 1 upon 2 minus 1, which is this. So the correct answer is option 2. That is, it is proportional to 1 upon root of E. The next question says the probability of is Z, that is eigenvalue having eigenvalue h cut by 2 for a given state is what? This is in any standard book of quantum mechanics that you know that it can be expressed in terms of Pauli's matrix, the Z component. And if you find the eigenvalues of that, you will get two eigenvalues, that is h cut by 2 and minus h cut by 2. The corresponding eigenvector being 1 0 and 0 1. We're going to use this, okay? So let me name this like this. And it's unnormalized as you can see here. So just put 0 1. So you can easily find this with a square. Final answer should be 2 by 5. Here goes another question. The ground state energy of an harmonic oscillator is given as 2m omega square x squared plus 8m omega square plus 18m omega square z square. So, what's the ground state energy? So, it is given by half of 4. We can write it as this. Okay, let me write in this fashion first. I hope you can understand why I'm proceeding in this manner. I'm just writing in terms of harmonic oscillator potential, as writing in terms of half of the entire thing. 6. From here you get n plus nx omega ny plus 1 h omega plus nz. Ground state, this should be 0, this should be 0. So the final answer comes to take it as a common. 2 omega plus 4 omega plus 6 omega कितना होता है 12 omega. Okay, that's the final answer. So next question says that what is the ratio of rotational energy for so rotational energy is actually given by this formula. So we can apply this. Right, 4 plus 1 divided by 6 4 into 5 divided by 6 into 7 2 by 3, so it's actually 10 is to 21. That should be the answer. Moving to the next question, ratio of second nearest to first nearest in FCC. How can I do this? Okay, I'm referring to a chart. Okay, so for SCC, you may note this. If you are going to take another exam, uh, some other exams, it might be helpful. So this is nearest. This is next nearest. This is next to next nearest. Okay, next and nearest, second nearest, and third nearest. So nearest is A root, sorry, A root 2 and A root 3. Then this, okay, this is the distance, and this is the number. You might take a note in a separate manner. So it's I'm not. Okay, you just things. Our main intention here is knowing this thing and this thing, the ratio of this. So the second nearest is A divided by A by root 2, which is root 2. Simple. So we have another question which goes allowed transition for gamma ray Ji to J, that is 7 by 2 to 3 by 2, which are allowed. So they're saying it's M1 E2, E2 M3, or M3 E4. Just uh, use this chart. Parity change क्या होगा right cross cross right right cross right cross if and only if L is odd form. Okay, so you can see the parity hasn't changed, so you can have this number of terms. This will be plus. Have 2 to 5, right? So 2, 3, 4, 5. What are the options? Parity has changed. Yeah. So M2 should be correct. No, sorry, parity hasn't changed. So E2 should be correct. And M1 should be correct. As parity. So yeah, this should be correct. Which particle is used for studying nuclear charge distribution? Is the electron scattering experiment? So that's find Bragg's angle in a tetragonal plane, sorry, crystal. Value of the parameters given like this, and lambda is also given. This you should do 2d sine theta equals to lambda. D is equal to sorry, h square by a square plus square plus c square. Okay. Just put what's happening. Yeah. So let me write here. D. The value of D must be calculated. So it's 1 as given. These are the Miller indices provided in the question. So you just put the values and see. And C is okay, L is 0. So we don't need to bother about it. Just find the value, put the value of lambda. You can easily find the angle by using your calculator. An electric field is supplied. You need to find the time derivative of E. So there is another question that which of the following is an eigenfunction of Lz. So the options are given in this manner. Cos phi sin phi, phi plus iota sin phi, and sin phi minus iota cos of phi. Okay, so you know that the formula of Lz. Apply, and you will get some eigenvalue and this function. I'm choosing this because this is going to be the correct answer. I already know. So it's and if you just take this iota inside, you will get this. And h cut comes the eigenvalue. On the basic very basic definition of eigenfunctions. Professor solver. So there is another question which is saying that we have 16 fermions spin half in one D box. We need to find the Fermi energy. So 2s plus 1. So 2 should be the degeneracy. We square h cut square pi square to 1 square h cut pi square divided by 1 square 1 square plus 2 square dot 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 h square. So I have a formula, right? Plus 1 to n plus 1 divided by 6 or something like that for the sum of the squares. Can we put that? Let me try. It's not working actually. Is it or it's n of? I need to check. Wait a minute. Yeah, it's here should be n. It's 9 into 17 divided by 6. So it's 4 by 2. So you can find a value and that should be the correct answer. So here goes another question that which is a wrong option regarding nuclear force. It is charge independent. Yes, charge independent. Right option is given, but we need to find the wrong option. But yeah, it's 10 to the power minus 15 meters only. So short range is the correct option. And spin independent. No, 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 not at all. Studied nuclear force in a big detail, you will know that it's actually not spin independent. It's spin dependent. This is the correct option for this question. Okay. Another question on the conceptual that they're saying that gluons are bosons, something like that. I don't remember the question. Gluons are bosons. That's the correct answer of the question. So another question goes like we need to find the eigenvalue of this matrix. So let's do it. So this should be the correct. We need to find the square root of this complex number. For finding the square root of a complex number, if you take this as x, sorry, this as a, suppose this is a, this is b, a plus ib, the normal form, and the square root form be x plus iota y. So x is given by a plus whole root by 2, and y is given by this. So I request you to check for some of these two formulas. You will get the formulas in HK Dash or some other book. You can have a Google search. Okay, the sign and the orientation of this. Just have a look on this, and you may comment that it's written right or wrong. So the next question, the wave impedance becomes free space. If you read the electromagnetic wave chapter in your, we have studied this in BAC. It's actually given by this. If you calculate, you will get 377. And this is a very common question. This type of question लोगों को रटा होना चाहिए if you have practiced very hard and you know how to process this. Mm. This is the equation, and we need to comment that is it a pole, isolated singularity, or removable singularity. You know the conditions. Do you know how to expand by Laurent series and all? You need to study that. So the Laurent series says that the sum of an and sum of bn of something and something. That is, this is actually z minus z naught, and this is z minus z naught to the power. That's the expansion. So if this bn terms goes to infinity, see, I'm not going to discuss concepts here because that's not the target for making this video. Obviously, I'm going to do the concepts in my future videos if I can, but my motive is to just discussion the question so that it helps the future aspirants. So this is removable. What I'm saying, it's bn is 0 removable. That is आप लोगों को डिनोमिनेटर में कोई z वाला टर्म नहीं मिलेगा and this is finite. bn कहाँ ना कहाँ थम जाएगा, that is ये डिनोमिनेटर कहाँ ना कहाँ थम जाएगा और ये infinite not convert. So it's very easy, just use the sign expansion, off series expansion, x minus x square factorial plus, oh sorry, it should be cube, yeah. What will happen? This z and this ultimately will get cancelled, and after all, you will not able to find any denominator in terms of set. So obviously, it's a removable singularity. Okay, so I would like to end this video over here. I've discussed many problems. In the next part, I'm going to discuss the other problems. Okay, so hopefully you have liked it, and some of the problems I think I have missed out in the middle. I'll try to discuss that in the subsequent videos. Okay. Oh, thanks for watching the video.